let's take a scenario that you guys are 3 months before tapeout. You got to do sign-off, and 3 blocks, 3 big complex blocks. So you start running the blocks, 2 runs per big block, and it takes 3-4 days. Those are big blocks. And surprise, it doesn't converge after 4 days. So you change the scripts and run it again. This time, 2 runs got stuck, 1 didn't converge, but you have a lot of time. Again, and again, and this is what we do, and again, and again, and again, and again. Here you are 1 month before tapeout, and it still hasn't converged. What do? Well, you don't need to worry about those stuff anymore, because in the cloud, why run 6 runs? Take 60 runs. Take 6,000 runs. At the end of the day, engineering should never stay idle, and if you can pull in the project, why not? Another interesting point, and I had several discussions with some of you here, is related to the cost structure of the project. Now, I'm not talking about what happens if you utilize engineering in a better way and pull in the schedule, or what happens if you miss the tapeout schedule and you're led to market. Let's talk only about the cost of the project. So this is Annapurna. We did our own survey. And for us, and by the way, for some other customers, this is the breakdown. You guys are 50%, your salaries are 50% of the project cost. 20%, about 20% is licenses. And then you have IPs, you have the tapeout. Infrastructure and IT are only 5 to 10%. And the question is, what can you do with this small chunk in order to affect the 50% and maybe pull in the schedule and maybe get much more? So up until 5, let's talk about how to run faster utilizing the cloud. And there are 6 things that I'll briefly touch. So this is a week in, again, our Annapurna chip, Graviton chip. You can see the spikes. Sunday, Monday, we work on Sundays. So Sunday, Monday, Tuesday, Wednesday, Thursday, and that was the weekend off, at least that time. You can see the peaks. We cut the baseline, but every week behaves in a similar way with the peaks. Now, if you were to buy computers for your own data center on-premise, I would assume that most companies would not buy compute for the topmost peak, because it's expensive. And then all the yellow, orange part, that's compute that you purchased and you're not utilizing. It's a waste. So each one of you would choose a point. Any company would choose the relevant point. And still, the orange section is still unutilized, but hey, it is what it is. But you're losing the white peaks. And this is where you guys may stay idle. And this is where you might compromise on how many DFT runs to do, how many jobs to run, how many Aprisa run to runs. Do you run machine learning and utilize thousands of machines, or do you give it up because you don't have it? So that's not a problem in the cloud. You could just do it. Now, if I were you, I would say, okay, this AWS guy is saying that the cloud solved the compute problems, but he didn't solve the license problem. And yeah, licenses are a bottleneck. So nowadays, licenses are kind of a solved problem if you go and talk to your Siemens folks. So if you need more stuff, go talk to them, and together you'll make it happen. In my presentation here, since AWS is not controlling how many licenses you would have, so after you got all the licenses that you need, I'll talk about what you can do with the licenses that you have, how to better utilize them, run faster, and how to better utilize your engineering. So we have a great collaboration with Siemens, and we're thankful for that. Part of the things that we did together, and we'll talk about how to utilize specific CPUs and our CPUs, but there are flight plans, which is a recipe of how to best utilize Siemens tools in the cloud. And this is, again, a benchmark that we did at Annapurna. And as you can see, Caliber results, it dropped from about 10 hours to about 4. Now, if it's an overnight run, who cares? But 4 hours is already something that you can run during the day. So if something didn't work well overnight and you need to fix it now, you don't spend the day. You can do 1, 2, 3 runs, depending on what you need, and save the day and pull in the schedule. So that's one example, but it's Caliber, it's DFT, it's anything that requires a bit more compute. So, 1, 2, 3, yeah, okay. Another thing to take into consideration is if you're looking at your own data centers, so the refresh rate is usually around 4 years. You get new compute around 4 to 5 years. That means that, again, if you're not running in the cloud, probably you have computers from the new generation. You have the previous one, and 4 in a row. Now, Intel did a benchmark on their own CPUs, 4 generations, 3 in the current one. And as you can see, this is EDA-based benchmark. As you can see, each generation is better from the previous one in about 50 to 36%. So let's say you have your on-premises data center, and you should run, and you get this last machine. That means that you guys are waiting twice the time, and the license is also taking twice the time. Why not run on the latest generation? So it's a point that when you're going to the cloud, you can always run on the latest one, unless there's a good reason not to. And the cloud gives you the opportunity to choose what's the right thing to do. Now, if we're talking about the flow to make PCBs, to make chips, so every section, whether it's front-end, back-end, or production, is different compute. If we're talking about back-end, probably it's multi-CPU, a lot of memory. If we're talking about front-end, probably 1 core, but should be fast. And if we're talking about yield and post-production, there are a lot of things that can be done with AI and utilize that. So again, if you have your own data center and you have only 1, 2, 3 types of machines, you use what you have. And if you use a backend machine for verification, it works, but it would take a lot of, it would consume a lot of money from that thing, and it's a waste. The other way around probably wouldn't converge. Again, in the cloud, you can pick and choose exactly the type of compute that you need. Now, AWS has lots of instance types, hundreds. One of them is, as an example, monster machine for big backend type of jobs. And this comes from a collaboration that we did with Intel. You can't find this machine outside because it runs at 4.5 gigahertz, all cores, all in turbo mode. And the reason it's possible is because the cooling and how we cool that in our data centers. And this is why when you need a big caliber backend, any big run that requires such a machine, you can take the job, the specific job, and run it here. Another point that you might not have thought about is which type of CPU is being used. And if it's Intel or AMD, some of you may know, the caching per generation is different. That means that per a specific design, with a specific tool, one or the other might be better. And you wouldn't know in advance. So you have to test. And it's very easy to test in the cloud. You also have Graviton, which is our Annapurna CPU. It's ARM-based. And because it's ARM-based, so the software has to be compiled for ARM. Now, it's again a collaboration between Siemens and us. And the tools are slowly being supported. You see a partial list, which keeps get updated. But ARM themselves did a benchmark at the time, and they compared it to the x86 at the time. And it's all EDA tools. As you can see, there is a difference. Now, it's not always the case. It's important to be able to test, and we have benchmarks where this is not the case. Sometimes Intel is better, sometimes AMD is better, and sometimes Graviton is better. But you have the power to test and see what has the best performance and what has the best cost per that performance, and then you can make the decision. At the end of the day, out of the hundreds possible compute types, we would recommend you only 2 or 3 per type of tool or per part of the flow, because the characteristics is pretty similar. So whether it's Intel, AMD, or Graviton, you need to test. And only you would know, what's best for you. I would just say that in addition to that, nowadays, there's also all the machine learning and the support of the tools with GPUs. So as you can choose AMD, Intel, or Graviton, you can also choose computers with NVIDIA GPU, with Intel GPU, or with AWS GPUs. The reason, again, it's Annapurna and the system that they created. And at AWS data centers, it's always with that system, the Nitro system. And the Nitro system is offloading. It's a chipset that offloads the main CPU, doing all the networking, the storage, doing the hypervisor, and security. So at the end of the day, your CPU is used mostly to do the simulation that you want, and not all the rest of the work. So actually, on the cloud, it might work faster because of the offloading. Then there's the question of latency. Actually, both latency and with all the chip acts, where is the data stored? So this is a slide that keeps getting updated all the time. Currently, we have 33 launch regions where you can provision compute. Sometimes you have to provision compute in Europe. Sometimes, if you have an extended team, you can provision compute near the team if it makes sense. If latency is an issue, you can do an architecture globally and use it in the right place. So, not sure if it went pretty fast, but those were 6 things that combined are pulling the schedule. If we talked about waiting time, so engineers should never wait for compute because they are the most expensive, it's easy. Taking the right compute definitely can affect the speed. Taking the latest generation, we saw, could be 2x faster. Different CPU types. I won't get into benchmarks now, but we can take it offline. We have lots of data about benchmarking. Then you have the Nitro system, and it's very, very easy to test. You can shoot the same job 3 times, 4 times with different type of memory, compute, and just see what works best and what costs the least. Now, the next slide I added, the next 2 slides, I added after talking to several of you guys here. Because the notion was, okay, so cloud can help us pull in the schedule, make more with less, but is it secured? So there's a notion, if you Google that, go for EDA Cloud Alliance, TSMC, Intel, Samsung, and others are all part of the alliance to allow EDA run with their PDKs in the cloud. So it works for years. I think this was published in 2018. So if you're not there yet, you're not the first. Multiple customers have already taped out in the cloud and also in advanced nodes. And then the next worry was, hey, but maybe it's okay, TSMC allows us, but maybe it's not secured. So at AWS, there's a notion of who owns what. It's called the responsibility sharing model. And what that means is that AWS is responsible for the security of the cloud. Nobody would come and take the computer. But you guys are responsible of the security in the cloud. Which data you're putting, what are you allowing? Anything you do with the data, it's yet another data center. If you have 2 data centers, whatever you did to the second one, you do to AWS. It's your data center. If you want third parties to be part of the security, you just do that. Whatever you do, it's yours. If you decide that nobody can connect if not from the office, you can do that or anything else. So it's as flexible as your own data center, and the responsibility to make sure it's secured is yours. Of course, we can help. Of course, we have partners that can help, but it has been done many times. Now, it doesn't mean that you have to go all in AWS. For actually many companies, it's a journey. You already have compute. You won't throw it away. So you can go hybrid. And then you can do chambers of, if your compute on-prem was depleted and you have peaks, you can use AWS. And then after 2, 3, 4, 5 years, you can make a decision and see whether it makes sense to stop handling all the overhead for your own compute or not. As we can see in the trend, it's usually going to the cloud. That's the trend. And the reason is the agility, and because you can do things that you couldn't do before, as AI, as pulling the schedule, as not compromising on quality. You also have the ability to make the security characteristics once, approve it, and then every system that you load would use the approved characteristics. So if you now have a bug with the tool that you want, God forbid, other vendor to see, you can ramp up a computer, put everything there, decide how secure you want it to be, and then when it's done, just kill it. So lots of options, and at the end of the day, security is solved for the semiconductor. The question that we ask always when we get such questions is, who is the networking security guy? What are your concerns? What do you want to do? How do you want to protect it? How do you protect your own data center? And as soon as that's the discussion, we just do the same as the on-prem data center. I'd like to briefly touch the compute models, because I heard also questions about that, and how to predict how much would AWS cost you for your specific project. And there are kind of three models. The first one is on demand. You need it, you use it by the second, and when you don't need it anymore, you kick it away and stop paying. So that's the model that costs the most. And then you have a model of reserved instances. And if you remember the first graph with Annapurna and the peaks, there's a baseline. And this baseline that is being utilized all the time, you could take it for a year, for 3 years, and then you get significant discounts. So when you guys, all pricing is public. You can Google everything. There is a price calculator. But a lot of customers are doing the mistake of looking at the on-demand price, which is more expensive than this one. And the last point is spot instances. Spots are spares of the database, of the data center. And you can get up to 90% discount. It's a huge discount. Actually, ARM does a very good job. There's a reInvent session where they're talking about that. And you can utilize those. The only caveat for spots is that we can take the spot from you with a 2 minutes notification. So probably you wouldn't run a 3 days job, at least in the past. But short DFT runs up to 1-2 hours. It makes sense because it just makes sense statistically. But nowadays, there are third parties and solutions that are anticipating when we are going to take the compute and making a save of the run, moving it to a different computer. You're not doing anything. You just run the job. And then you can benefit from the spot while it shifts back either to on-demand or back to spot as the dynamics goes. Then you might ask yourself, okay, so for my project, can I know how much it would cost me? And there's a very simple way to do that. You can go to GitHub. There's an HPC cost simulation, that simple script that we made. And this runs on your log file. And everything is within, it's contained to you. You control it. Of course, we can help you. But what you get out of it is an analysis of how much time and how much compute you were running. And then we can look together and see, okay, so here's a baseline that you're always running. This is the saving plan. Here are jobs that are running for relatively short time, spots. And here are jobs that you have to take on demand because it was an unexpected peak. And then this is the right way to actually look at the cost itself. And you have, again, you can Google it. You have a calculator. You can plug in all the numbers based on the table and come to a number. And then, talk to Siemens, talk to us. We'll be happy to help you. The last part is controlling the cost. And it's an important part, because if you can run as many as you need, it's a concern for project managers, the CAD, the budget. How do we control the budget? And since it's API-based, you can do anything. You can get notifications after a few days that you might go beyond budget at the end of the month. What do you want to do? You can get notifications and send automatic emails to specific groups. You can kill jobs. Nobody does that, but you can do anything that you want to control the budget. And what it allows you is when things are not on the critical path, you can shut down the option for engineering. When suddenly you're before tapeout or have something that requires more, so you know that you put a bit more focus and then get it done. Last slide. So usually for takeaways, more than 3, nobody remembers. So let's do 3. The first one is the collaboration. And thank you very much for inviting us. It's a great honor to work with you guys at Siemens. We see the flight plan together. We see the Graviton. We see more plans coming along. And it's really great to be a partner. The second point I wanted you to remember is that you should never compromise on PPA, on quality, and on schedule. When you need to run jobs, if you really need them, run them. If you can do more, do more. If you need to do more, do more. You can do that, and it's pretty easy. And the last point, as we said, you guys are, the resource that costs the most. If you guys can do more with the licenses that you have, everything would be cheaper in the project level, and you could pull in the schedule or get better quality. Thank you very much. Let's go drinking.